And now let's take a look at some functions that are maybe factored. Okay, so if they're not factored, hopefully you realize that by now that you will have to factor them in order to get them into a form where you can analyze the whole thing. So here's an example here for graphing completely. So f of x equals x plus 3, say, x minus 2, and maybe x minus 5. Okay, so make it a cubic on the top, and then let's make it a linear on the bottom, and just make it simply x plus 1. Okay, so there is a cubic divided by a linear, and you know that the end behavior here is going to be like a quadratic. The leading coefficients are 1. Okay, so you can say that the end behavior, I'm going to call it EB, is basically y equals x squared. So it goes off like that. Okay? Now, we're going to have no horizontal asymptote because we have the end behavior like this. Okay, so when the degree of the top is bigger than the bottom, there is no horizontal asymptote. Okay? Now, the vertical asymptote will be when x equals negative 1. Okay? And the zeros are at x equal to negative 3, 2, and 5. Okay? So those are the zeros. So now we can go ahead and try and graph this. All right. So let's put the vertical asymptote. Notice I'm always labeling my axes. Okay, vertical asymptote at negative 1. So x equals negative 1, label that. And then put in the zeros. So we've got x equal to negative 3. Okay, negative 3. And then we've got x equal to 2. And x equal to 5 as the zeros. Okay, so we know the end behavior is like y equals x squared, so it goes up like that and like that on the ends. Okay, so after 5 here, it's going to go up. So what's going to happen? It's going to come down like this to 5. Okay, it's also going to do the same thing at 3. Okay, it's going to come down like that. Has to hit the x-intercepts. Okay. Now, this has to hit this x-intercept here, so we can check out a couple of things here. We could check out the values in between here, between 2 and 5. We could check out f of 3 and see what the sign is, whether it's negative or positive. So let's do f of 3 equals, well, let's plug in 3 here. 3 into that is positive. That is going to be positive, and that's going to be negative. So the top is negative. The bottom will be positive. So f of 3 is going to be a negative, so it's down here somewhere. Okay? And then we could also try and see what happens at in between 2 and the asymptote to see if it comes down and then hits this and then goes back down again. It shouldn't really, because this is not a squared factor, right? If it's squared, it might come and touch and then go back down. Because they're not squared, they shouldn't, but we're just checking it out. Okay, so let's try f of 0. F of 0, well, that's positive, negative, negative. 2 negatives make a positive, and the bottom will be positive, which equals a positive. So in here, the function is going to come down in here because it's a negative at f of 3. And then it's going to come back up, hit 2, and then it's going to be positive. So it's going to head up like this, and it's going to give you the head to the asymptote that way. Now the question over here is, does this come down or does it go back up? Well, again, I'm guessing that it comes down because this is a linear factor. If it was squared, it might hit and come back up. But I'm guessing it's not. So let's try something in between negative 3 and negative 1, which is negative 2. Okay, so in f of -2, if you look here, that's going to be a positive, negative, negative. Two negatives make a positive. Okay, and then -2 on the bottom, well, that's going to be a negative. So that gives me a negative here. So f of 2 is negative, means down here, and it's going to head towards the asymptote this way. And that would be our graph. Okay, so the end behavior is like a quadratic, so if you went way out, you could say that it has a quadratic asymptote. Okay, so this function approaches a quadratic as x goes to infinity and negative infinity. Okay, what about this next example here? So let's try and make something up a little bit different, maybe a little bit harder. So let's do a squared term on the top, so x plus 3 squared, then x minus 2, and x plus 1. Okay, so that gives us a quartic on the top, and let's do a quadratic on the bottom. So x times x minus 4. Okay, so we've got a quartic on the top and a quadratic on the bottom. So what does this tell you about the end behavior? Degree 4 divided by degree 2. So the end behavior is going to be y equals x squared again, because x to the 4 divided by x to the 2 is x squared. So we know that the end behavior is going to be like a quadratic out far. The vertical asymptotes, again, no horizontal asymptote when the degree of the top is bigger than the bottom, okay, because it behaves like a polynomial. Polynomials do not have horizontal asymptotes. Okay, so the vertical asymptotes, okay, often people forget this x1 when x is there. Well, x can't equal 0. So there's a vertical asymptote at x equal to 0, and another one at x equal to 4. And then the zeros, well, they are x equal to -3, -1, and 2, the values on the top that make this 0. Okay, so let's see what we get when we plot this. So we've got the x, the y. Let's put in the vertical asymptotes. Well, we got the y-axis is 1. Okay, so y equals 0 is a vertical asymptote. And we've got x equal to 4, or not y equal to 0, sorry, x equal to 0, and then x equal to 4 is another vertical asymptote. Then we put in the zeros of x equals -3. Okay, so -3, say there. And then we've got -1. And then we've got 2. Okay, so those are our x-intercepts. Now, looking at the end behavior first. The end behavior out here, it's going to head up like a quadratic. There are no zeros in this section here, so it cannot touch the x-axis or go through it. So the only option, because it can't touch or go through it, is to go back up, like that. Okay. Out here, at the 3, well, it's going to go like this, like a quadratic. And what happens on this side? Well, we need to check. So my guess is that it's just going to touch the 3 because that factor is, touch the -3, that factor is squared. So my guess is it's going to come back up and then come back down to this one. Okay, we'll see. Remember, this is a vertical asymptote. So let's check some numbers here. So let's do on this side first here, f of 1 and f of 3 to see what happens at this 0. Maybe it touches and goes up or goes through and down. So let's try f of 1. So f of 1 we plug in here. That's going to be positive, negative, and positive. So the top will be negative. On the bottom, put in 1, we're going to get a negative. So that equals a positive. So f of 1 is up here somewhere. F of 2, or f of 3, okay, that equals, well, that's positive, positive, positive. Okay, so positive 3, that's going to be a negative, so the bottom will be negative, which equals a negative. So around 2, on this side, it's up here, so it's going to come down like this, head towards that asymptote, but then it's going to be negative between 2 and 4 because of this. So it's going to come down like this. Okay. Now, let's check out some numbers over here. Let's see if it actually pops back up between negative 3 and negative 1 by checking out f of negative 2. Okay, so f of negative 2, well, we want to see whether it's positive or negative here. So negative 2 in here, well, that's going to be positive. It's always positive because it's squared. Negative 2 minus 2, that's negative. Negative 2 plus 1, that's negative. Negative times a negative is a positive on the top. Negative 2 on the bottom, a negative, and negative make a positive. So that equals a positive, which means f of negative 2 is up here. So it does bounce back up. It goes up, and then it has to come back down to negative 1 because that's a 0. That's an x-intercept. So does it come down this way, or does it go back up that way? Well, now we need to try 0.5 in here. Okay, so f of negative 0.5, that is. Okay, so I want to see whether that goes down or pops back up. I'm guessing it goes down because x plus 1 is not squared. Okay, you'll get the hang of this. You won't even have to do this in the future, just for some of them. Okay, so let's try negative 0.5. Well, that's squared. It's always positive. Negative 0.5 here makes that negative. Negative 0.5 here is positive for this factor. So a negative times a positive is a negative. And then at the bottom, negative 0.5 here. Negative 0.5 here makes that negative. Negative times a negative is a positive, which equals a negative. So f of 0.5 is negative, so it must come down to the asymptote that way. And that would be the function of the graph of this function sketched as much as we know.